So let's do another problem. And for this one, we'll go a little bit faster, but the overall method's going to stay the same. So I'm going to first rewrite it. Let me just make a little more space. So we have that our function is 1/5 x squared minus 2x minus 1. And we're going to complete the square so that we can turn this into our vertex form. So remember, you want to isolate the variable terms and factor out whatever the coefficient on x squared is. Since if it's not 1, we essentially need to factor it out so that we can make it 1 within the parentheses. So we're going to factor out 1/5, and here we're left with x squared. And remember, when you're factoring out, you're really just dividing by the number you're factoring out. So we're taking 2 and we're dividing it by 1/5, but that's the same as multiplying by the reciprocal, which would be 5/1. So minus 2 times 5 would be minus 10. And you can check this by just redistributing. And I'll leave a space so that we can complete the square and put the minus 1 on the outside. Now, let me just rewrite our formula for completing the square. And essentially, we just need to figure out what our a value is here. But we can compare it to this formula. Notice that the coefficient on x is always twice a. So in this case, our coefficient on x is minus 10. So that means that twice a is minus 10, or that a is minus 5. And the number we have to add to actually turn this into a perfect square is a squared. So minus 5 times minus 5 would be positive 25. So we're going to add 25 within the parentheses so that we can transform this. It'll become 1/5 times x minus or plus a, but a is negative 5. And that'll be squared. Now we want to be careful with the constants here because we didn't add 25, we really added 1/5 times 25. And 1/5 times 25 is 5. So we added 5 here, so that means we also have to subtract 5. So it becomes minus 6 on the outside. And so now we have our vertex form. So we can write down our vertex. The x value that makes this term 0 would be 5. And when we plug 5 into the function, this whole term goes away, and the y value is minus 6. Now, for this problem, I did mention I'll move a little bit faster, and we'll assume we're using the interactive grapher that's linked in the description. So one of the Khan Academy exercises. And for this, I'm just going to pick an x value so that my function would simplify to a nice clean whole number. And then I can plot that point, and the interactive grapher will essentially just fill in the rest of the points for me. So I could plot the intercepts if I want to get a really clean, accurate picture. But if I'm using a computer grapher, then really I just need to pick one other point, and it'll find the rest of them just by filling it in. So notice here that we have division by 5. So I want to pick a value here so that when I simplify it, this is also a multiple of 5 so that we can make a cancellation. So I want this on the inside to be either 5 or minus 5. So if I choose an x value, let's say of 10, and I plug this in, then I'd get 5 squared, which is 25, which I can then cancel out with this 5 below and just end up with 5, since 25 divided by 5 is 5. If I choose a different number like 6, then I end up with 1 squared, which is 1, and I get 1/5. And so I'm going to have a fraction which the interactive grapher may not be able to handle. So I want a nice clean whole number. Now I could also use x equals 0. In fact, both of these points are going to be symmetric. They're going to have the same y value because they're equal distance from this x value of the vertex. But if I plug in 0 here, then I get minus 5 squared, which is also 25. So like I said, both of these will give us the same value. So g of 10 and g of 0 will be the same y value. And when I plug that in, I get 1/5. Let's do 10. And so that's 10 minus 5, which is 5 squared. And 5 squared is 25, and 25 divided by 5 is just 5. So I get 5 minus 6, which is negative 1. So I just found two other points at 10, comma, minus 1, and at 0, comma, minus 1. So let's start graphing these. I need to draw a coordinate plane for all of this. And let's start with the vertex. So that's at 5 comma minus 6. So that's going to be right about there. And then we have these two other points, 10 comma minus 1. That'd be right about there. And at 0 minus 1, which is right there. So now if this was the interactive grapher, it would just fill in the rest of the curve. So I will draw it really briefly here. And so this isn't going to be perfectly accurate if you're doing this by hand, because I'm basically guessing what the x-intercepts are. I do know the y-intercept because I just happened to pick that point, but the x-intercepts I guessed. So that's the drawback with this method. If you want to be very accurate by hand, then you really need to find both of the intercepts. But like I said, if you're using the interactive grapher, then you really just need to pick one point and the vertex and just make sure it's oriented in the correct direction.